Solution of numerical problems of the chapter cross product. Numerical number 1. Find the magnitude of torque of a force minus 3i cap plus j cap plus 5k cap Newton acting at a point 7j cap 7i cap plus 3j cap plus k cap meter. According to numerical number 1, force vector F equal minus 3i cap plus j cap plus 5k cap Newton. This is force vector, and in the question there should be a Newton. The unit of the force should be Newton, and perpendicular distance vector is 7i cap plus 3j cap plus k cap meter. Mod vector tau is equal question mark. That is, we have to find the magnitude of torque acting on the body or on the particle. Now we know that vector tau equal vector r cross vector f. That is the cross product between the perpendicular distance vector and force vector. Now we can write determinant. This is determinant with I cap, j cap and k cap. Below this we can write 7, 3, 1. Putting the rectangular components of perpendicular distance vector r. Below we can put down the rectangular components of force vector. Now as we have vector r cross vector f, vector tau is equal to vector r cross vector f. That's why below I cap, j cap, k cap, we have to put the rectangular components, that is 7, 3, 1 of perpendicular distance vector r. Then we can put the rectangular components of force vector. Now we can write 3 brackets with I cap, j cap and k cap. We can write 3 brackets with I cap, j cap and k cap, and writing 3 into 5 minus 1 into 1, that is 3 into 5 in minus 1 into 1. And how to find these rectangular components? Doing cross multiplication between 3 and 5 and 1 and 1, and difference of them will be 3 into 5 minus 1 into 1. That will be the rectangular components along x-axis, rectangular components of torque along x-axis. Similarly, we can write 1 into minus 3 minus 7 into 5. Minus 7 into 5. Now blocking j cap, immediate right hand rectangular components of j cap is 1. That's why multiplying 1 into minus 3 minus 7 into 5. Minus 7 into 5. Then for finding the rectangular components of k cap, we can write 7 into 1 minus 3 into minus 3. Finally, we get vector tau as equal 14 I cap minus 38 j cap. And what about the rectangular components with k cap? What about the rectangular components of with k cap? It should be 16 k cap. We get vector tau as equal 14 I cap minus 38 j cap plus 16 k cap. That is what? The torque vector, and unit of torque will be Newton meter. We know that vector tau is equal vector r cross vector f. That's why unit of torque will be Newton meter. Unit of torque will be Newton meter. Vector tau is equal 14 I cap minus 38 j cap plus 16 k cap Newton meter. This is the torque. This is the torque vector. This is the torque vector acting on the body. Now modulus of vector tau or mod of vector tau is equal. We know that if vector A is equal ax I cap plus ay j cap plus az k cap, where ax, ay, az are the rectangular components of vector A, then mod vector A will be equal root over ax square plus ay square plus az square. That's why we can write the mod vector tau will be root over 14 square. Root over 14 square plus under bracket minus 38 whole square plus 16 square. Root over 14 square plus under bracket minus 38 square plus 16 square. That is the magnitude of the torque or modulus of the torque acting on the body. Therefore tau will be equal to 43.54 Newton meter. Tau will be equal to 43.54 Newton. That is the value of magnitude of torque vector. The value of the magnitude of torque vector, or this is the magnitude of Tau is equal to 43.54 Newton meter. This is the magnitude of torque. Numerical number 3. Proof that 2 I cap minus 3 j cap minus k cap and minus 6 I cap plus 9 j cap and 3 k cap are parallel to each other. That means we have to prove that the two vectors will be parallel to each other. According to numerical number 3, vector A is equal to 2 I cap minus 3 j cap minus k cap. Vector B is equal to minus 6 I cap plus 9 j cap plus 3 k cap. Therefore, vector A cross vector B equal determinant I cap, j cap, k cap. Below this we can write 2 minus 3 minus 1, and below this we can write down the rectangular components minus 6, 9 and 3. Now writing 3 brackets with I cap, j cap and k cap, and rectangular components of I cap will be minus 3 into 3 minus 1 into 9. With j cap, what we can write, minus 1 into minus 6 minus of 2 into 3, and rectangular components component of I k cap will be 2 into 9 minus 3 into minus 6. We get minus 9 plus 9 I cap, then 6 minus 6 j cap, plus then 18 minus 18 k cap, equal 0 I cap plus 0 j cap plus 0 k cap. We get vector A cross vector B as equal vector A. Therefore, we get vector A cross vector B as equal 0 I cap plus 0 j cap plus 0 k cap. Vector A cross vector B is equal to 0 I cap plus 0 j cap plus 0 k cap. Therefore, mod vector A cross vector B equal to root over 0 square plus 0 square plus 0 square. Therefore, mod vector A cross vector B will be equal to 0. Mod vector A cross vector B will be equal to 0. We get the magnitude of cross product between vector A and vector B, which is equal to 0, equation 1. Again, vector A cross vector B is equal AB sin theta in cap. Vector A cross vector B equal to AB sin theta in cap. Therefore, mod vector A cross vector B will be AB sin theta mod in cap. We get mod vector A cross vector B as equal only AB sin theta, because mod in cap is 1. That's why mod vector A cross vector B will be equal to AB sin theta, which is equation 2. Comparing equations 1 and 2, we get AB sin theta as equal 0. Therefore, sin theta will be equal 0. Therefore, theta will be equal to 0 degree. Therefore, vector A will be parallel to vector B. Vector A is parallel to vector B because angle between the two vectors, that is theta, is 0 degree. Numerical number 2, a body is moving with linear momentum 4 j cap minus 3 k cap kg meter per second at a point I cap minus 2 j cap plus 2 k cap meter. Find the magnitude of angular momentum. According to this numerical linear momentum vector, that is vector P equal 4 j cap minus 3 k cap kg meter per second. That means it can be written as 0 I cap plus 4 j cap minus 3 k cap kg meter per second. Vector R is equal to I cap minus 2 j cap plus 2 k cap meter. That is distance vector, perpendicular distance vector, and we have to find magnitude of angular momentum vector. Angular momentum vector L is equal to vector R cross vector P. Determinant, symbol is determinant with I cap, j cap, k cap. I cap, j cap, k cap. Below this we can write down the rectangular components of perpendicular distance vector, that is 1 minus 2 2, then 0 4 minus 3. Then we can give the bracket with I cap, that is minus 2 into minus 3 minus 2 into 4 I cap plus what will be the rectangular component with j cap, that is 2 into 0 minus 1 into minus 3. Then with k cap we can write 1 into 4 minus 1 into 4 minus 2 into minus 2 into 0. So now we get vector L. Below this we get, if we simplify, then we get vector L will be equal to minus 2i cap minus 2i cap plus 3j cap plus 4k cap. That means we get vector L as equal minus 2i cap plus 3j cap plus 4k cap kg meter square per second. This is angular momentum vector. Angular momentum vector, and now modulus or magnitude of vector L will be minus 2 whole square plus 3 square plus 4 square. Therefore, L will be equal to root over 29. L will be equal to root over 29. Therefore, L will be equal to 5.39 kg meter square per second. Kg meter square per second. Angular momentum L is equal to 5.39 kg meter square per second. This is the magnitude of angular momentum. This is the magnitude of angular momentum of the body.